Hi, everybody. So, unfortunately, I can't be here today because I am at home taking care of my kids. So, I'm going to be showing you this video and we're going to go through the notes for task 7.3, which is in your TAN packet. If you could please open to those pages, we're going to get ready to go through these notes. So, our learning targets for today are we want to be able to create geometric symbols or notation to communicate with precision when we are modeling with points, lines, and segments. So we want to use the right symbols, which we've been talking a lot about. We want to be able to create visual geometric representations. So we're going to make our own pictures and use labels and markings in them to show geometric relationships. And we want to be able to create equations using segments to solve problems. And finally, we want to be able to evaluate expressions to find the length of a segment once we solve those equations. Let's go ahead and start with a warm-up today based on what we did last time we were here in class. So in this problem, it says that in the diagram, the length of AB is 34. I'm going to go ahead and label that on my picture. AB, the length is 34. Now we want to find CB. So we want to figure out how big the length of CB would be. CB in this picture would be this guy right here. That's our missing information. In order to find that, we're going to use the idea that the little segment plus the other little segment gives me the big one, or that we could do the big one minus the little one to get the other little one. In this problem, I would do the big segment, which is 34, minus the 18, which is right over here. And that's going to give me my missing segment length, which is 16 for CB. So my answer would say segment CB is 16 in length. Now, in the next problem, it says, in the diagram, the length of AB is 32. So we know that that segment is 32 units long. First, we're supposed to find the value of X, and then we're supposed to find the length of AC and the length of CB. Now, in this problem, we're going to use the idea that the little plus the little makes the big. So the little segment here plus the little segment here makes the whole thing. The first little segment is 3x minus 5 plus the second little segment is 4x minus 12. And all together, we get the length of the whole thing, which is 32. We're going to go ahead and solve this equation. And so my first step for solving is actually going to be to combine the like terms. So 3x plus 4x gives me 7x, and negative 5 minus 12 gives me negative 17. And then I'm just going to drop down the 32. Next, I'm going to go ahead and add 17 on both sides of this equation. And so we get 7x equals 32 plus 17 is 49. And then we can go ahead and we can divide. So if we divide by 7 on both sides of this equation, we end up getting x equals 7. So now we know x is 7. In order to find the length of AC, I'm going to use this expression, and I'm just going to plug in the number 7. So 3 times 7, because now I know that x is 7 minus 5, which gives me 16. To find the length of BC, which is this expression right here, again, I'm just going to go ahead and plug in the number 7. So 4 times 7 is 28, minus 12 is also 16. This is a quick warm-up review of what we did last time when you guys were here in class. At this point, I would really appreciate if you guys could pause this video and take the daily quiz of today. Okay, now that we've come back after our daily quiz, we're now going to talk about midpoints. So, the midpoint, this new word that we're learning is the word midpoint. In geometry, the word midpoint means a point that is exactly in the middle of a segment. It divides the segment into two equal pieces. We're going to go back and look at problems 1 and 2 and determine whether point C, this guy right here, is or is not a midpoint of those segments. Well, in problem number 1, when we look at the size of the segments, this guy is 18 and this guy is only 16. So C is not exactly in the middle. If we go to problem number 2, we ended up figuring out that the length of AC was 16 and the length of BC was 16. So C is exactly in the middle. That means that in problem number 2, point C is a midpoint because the length of AC is equal to the length of CB. So C must be exactly in the middle. Now, you'll notice if you just look at the diagrams for numbers 1 and 2, C looks kind of like it's in the middle for both. But we can't just assume that a point is exactly in the middle unless either we're told that it is exactly in the middle in the instructions, or unless we can actually find the lengths of the segments and prove it's exactly in the middle. Let's go ahead and take a look at the next example. So here's some new vocabulary we're talking about today. The vocabulary, the first term is congruent segments. I keep drawing with the pens when I mean to draw with the highlighters. Congruent segments. When we look at segments, two geometric segments are called congruent when they are the same. In this diagram, we can use tick marks to show that the segments are congruent. Let me write that neater. I feel like I did not write that very neatly. Tick marks. So in this diagram, you'll notice that there are two little lines here and two little lines here. That is my visual clue that these two segments are congruent. Now, we have a special symbol for congruent, so we're going to talk about that now. In this problem, we would say that segment BA is congruent to segment XY. But rather than writing out the whole word congruent, the symbol for congruent looks like an equal sign with a little squiggle on the top. Now, when two segments are congruent, we know that they have the same length. So two segments are going to be congruent when you measure them and they have equal lengths. In order to show that the lengths are equal, we don't use the congruent symbol. We say that the length of BA, and you'll notice I did not write the segment symbol on the top, is equal to the length of XY. Because we are talking about the length, we do not use the segment symbol. Whereas if we're talking about the segments being congruent, we don't use an equal sign. So little lines on the top, congruent symbol. No little lines on the top, equal sign. Okay, based on this diagram, we want to say which segments we see that are congruent. Now in this picture, I can see that there are tick markings right here. So that would tell me that segment EH is congruent, so I'm going to put like a little equal sign with a squiggle, to segment HF. You'll notice that because I'm using a congruence statement, I'm using the congruence symbol, and I'm using the segment symbol because congruent goes with segment symbols. Now, sometimes we're also going to be given information in the instructions. So here it says segment BP, which would be this guy, is congruent to segment CK, which would be this guy. If two segments are congruent, then we're going to add in our own tick markings to the diagram. Now you'll notice that here I decided to just put one little tick marking on each segment. You can put as many as you want, as long as you put the same number on both. Having the same number of tick markings means those two segments are congruent. Now, this ties into what we talked about at the beginning. When you have a midpoint of a segment midpoint, it means that you have a point that is exactly halfway between the endpoints. If, for example, you're told in the instructions that M is the midpoint of segment AB, it allows us to say that these two segments must be congruent because that point must be exactly halfway, which means both of those have to be the same length. When we name those, what we would say is that AM is congruent to MB. We could also say that the length of AM is equal to the length of MB. And you'll notice that when I use the congruent symbol, I put the little segment on the top. And when I don't use the congruent symbol, I don't put the little segment on the top. Now, another word that means exactly halfway is bisector. I like to think about bisector as meaning two sections. So a segment bisector divides a segment into two equal sections. Now, if we're told in the instructions, for example, that line PM is the segment bisector of line RS, then that means that segment RS is getting cut in half by line PM. It's slicing it in half. So we would say that RP is congruent to PS. Those two halves must be the same. We could say with symbols that segment RP is congruent to segment PS. Or we could say that the length of RP is equal to the length of PS. And once again, you'll notice that rule: segment symbol, congruent symbol. No segment symbol, equal sign. All right, how does this all tie together to help us solve problems? Well, sometimes we're given a problem like this. It says in the directions, mark the diagram to show the given information. Then write a congruence statement showing which segments are congruent. So my given information here is that E is the midpoint of AD. It's exactly in the middle. Segment AD is right here, and E has to be exactly in the middle. To show that with markings, we would put tick marks on the diagram. Now, to write a congruence statement, it's telling me use the congruent symbol. So I would say that segment DE is congruent to segment EA. For number 6 here, it says in the directions, name a segment and its midpoint using the information in the diagram. So name a segment and the midpoint of that segment. Now, there are lots and lots of segments in this picture, but the only time we know we have a midpoint is if there's markings. There are markings here and here, and those markings are showing me that this segment is congruent to this segment. So the big segment that got cut in half is the segment that goes from G to H. And the point that's cutting it in half, the midpoint, is I. My congruence statement would be that GAI is congruent to IH. The next thing we're going to do is use this with some numbers. So in the directions here, it says M is the midpoint of AB. And we can also see some markings in the diagram that show that those two segments are congruent. If that happens, then this is actually a typo right here. This should say AB. I apologize. Then MB must also be 13. They have to be the same because they're congruent. And that means that AB, this whole thing, would have to be 26. If you add those two up, you get 26. A congruence statement would be that AM segment AM, is congruent to segment MB. In the next question, it says, given that MD bisects TB. So MD is cutting TB in half. It also tells me that the length of TB is 62. Then I'm trying to find TM. Well, if I cut TB in half, then these two segments must be congruent. So I'm going to add some tick markings to my diagram. That means that I can find TM by just dividing 62 by 2, and that gives me 31. If I wanted to write a congruence statement here, I would say that TM is congruent to MB. Next, let's look at this problem. It says that B is the midpoint of AC. Now, if B is the midpoint of AC, then that means that this piece has to be the same as this piece of the segment. That means that these two lengths have to be equal. So we could say that 5x is equal to 3x plus 4. Now, this is an equation that we can solve. We would just subtract 3x on both sides, and that gives me 2x equals 4. Then we would divide by 2, so x equals 2. Once we know that x is 2, we can find all this other information. So AB can be found using this part of the equation right here. So 5 times 2, which gives me 10. BC can be found using this part of the equation. So 3 times 2 plus 4, which also gives me 10. And AC would be whatever I get by adding both of those up, so I get 20. The last problem we're going to do today is this one. It says here in the instructions that D bisects segment EF, and ED is equal to 4x plus 6, while DF is equal to 7x minus 9. The first thing it asks me to do is draw a picture. If I'm going to draw a picture, I'm going to start with segment EF. So segment EF here would be a segment that goes from E to F. Now it tells me in the instructions D bisects that segment. So D is in the middle, and not just anywhere in the middle, it's exactly halfway, which means I'm going to add tick marks to my diagram. ED is 4x plus 6, whereas DF is 7x minus 9. In order to solve and find x, we need to know that because that is a segment that was bisected, D is exactly in the middle, these two pieces must be equal to each other. It's exactly in the middle. Now, when I solve this, I'm going to subtract 4x on both sides, which gives me 6 equals 3x minus 9. I'm going to add 9 on both sides, which gives me 15 equals 3x. And then I'm going to divide by 3 on both sides, so I get that x equals 5. Now, if I want to find DE, I'm going to use this equation right here. DE would be 4 times 5 plus 6, which is 26. If I want to find DF, I know that DF is going to be the same as DE because that D is directly in the middle. So this is also 26. And then I can get the whole thing by just adding up 26 plus 26 and getting 52. That is it for today's video. What I'm going to ask you guys to do now is please go ahead and work on your homework for the rest of the class period, and I will see you next week. Thank you so much. Have a great weekend, and I will see you guys next Monday.